See, like there we go. All right. Hello, YouTube. I'm here with a lot of my colleagues in person, which is fantastic. So we're filming this during our offsite. You guys are wearing the same sweatshirt, and I'm not. I'm wearing a Pie Cascade shirt, and you guys all have a Kaggle shirt. Well, I'm left out. So this is Phil, who's been on Coffee Chat previously, and Wendy, who's been on Coffee Chat previously, and Jamie. Sorry, the joke is I call him Jamie. His name is Jackie, and he is an engineer on the datasets team, right?
Yeah.
And the reason I thought it might be cool to have an engineer here, besides our YouTube folks don't get much chance to talk with our engineering team, is because I thought it would be good to talk about testing. So I was at PyCon last week for me. This will be happening in the future. And there's a really good talk by Jess, last name, I can look it up, about testing and the role of testing in data science and where we should use it. And when I went back to look at the talk once the videos were posted, I saw that there was one about testing in data science from last year's PyCon and the year before when there weren't a lot of data science talks. So I don't know, like I know how I think testing should be used in data science, but I'm getting the sense that there's not a strong, like obviously in engineering, there's like, you know how to use unit tests and like, you know when you want to, and there's like strong, what's the word I'm looking for? Standards, I guess?
Yeah.
Coverage.
Yeah.
Coverage.
Yeah.
Listen, I don't even want to think about coverage, but like there's like disciplinary standards and everyone knows what to do. And in data science, I feel like we're just like, we don't have that yet. We're developing it as a discipline.
How do you unit test?
Actually, surprisingly, we have probably the most coverage of unit tests in this one particular project called Kaggle metrics. We do have very good test coverage there. And what it is that we have a bunch of competition metrics where we evaluate different performance of people's submissions, and we basically each tests basically pulls in a CSV file. Is it a CSV? I think it's code.
Yeah, it's a CSV.
It's a CSV file where it has like a sample submission or a simple submission, and we have an expected score that goes with the submission and the solution. So we run that.
So you have like a specific file that you're using. You're not like, is it a file or is it inline that you're sort of?
You can do it inline too. I actually do put some tests in there when I'm not sure.
Yeah.
But this is for testing the grading system, or
the scoring system.
Okay.
Yeah. So we have like variable inputs, and then we have results that we know we want from them, and then we can. It's like pretty straightforward testing for it. But like Wendy said, we have like pretty amazing test coverage there.
Because if that breaks, then every submission is going to be.
We work really hard to make sure that every submission is scored properly.
Yeah, because there's a little bit of dependency between different metrics. Like when we create a new competition that has a custom metric, sometimes we reuse like different functions. And if you change something, for example, if you change it from, I don't know, a floating point to integer or something, it might actually break other metrics. And people might get different scores, and if it's a live competition, it could be really bad. So we definitely do need tests there.
Definitely. And can you guys talk about, is it in Python?
No, this is all in C#.
It's on C#?
We use this package called NUnit. Is it XUnit?
Oh,
it's NUnit.
Oh, okay.
Actually, I think that one uses NUnit.
Okay.
NUnit. Okay, like letter N.
Yeah.
Okay, interesting. Do you both like write a lot of C#?
For metrics, yeah.
For metrics?
Yeah, now for
Yikes.
metrics. Yeah, I used to write a lot of C# for other stuff, but now I write it for metrics. Yeah, not here.
Not here. Okay.
Yeah.
I learned a lot from Phil.
Aw. I learned a lot from Wendy. Yeah.
I learned a lot from you both.
Yay!
Definitely. So do you usually, I don't know, so how much of the testing, how much testing do you do on the data set side? So I know when you upload a data set, we do some sort of like automatic visualization, not really like any processing, but what sort of testing do you do with data as it comes in? Because that's something that a data scientist would have to do if they were building their own pipeline.
Yeah, for sure. So we do. So for example, like we have all sorts of different compressed file types, right? And then when it comes in, we try to decompress them. And so we use different sorts of open source libraries, but like at the where they all integrate together, we do heavy unit testing on that. And so we have, like you guys, we have like for each of the compressed types, we have a file for that in our that we are going to test every time we make changes, right? And so that's what we do. And more specifically, and more like on the other side, other parts of the data sets, any kind of features that we launch, or most of the features that we launch, we do unit tests. I mean, I think the philosophy there for us is that as Kaggle grows larger and larger, then more people are touching the code base, and then it's going to easily break something if you, adding on something that you didn't know what it was supposed to, how it was supposed to work. So yeah, I think that's why we do unit tests.
That's fine. And it's getting to be more of a thing in data science teams as well, right? Like it used to be like, Adriana, who did all the data science for the entire company, and now you have like a tight team of people who are working together. And if you're working on like a pipeline or something, it makes sense. So do you, and anyone can jump in here, do you want to talk a little bit about what a unit test is specifically? Because there's different types of testing, right? Like there's hypothesis testing, which I know a lot about, and then there's this unit test. It's a statistics thing.
Sure.
That was a joke.
Phil, you should take this one.
Yeah. Yeah, well, I actually, partway through my engineering career, like back in like the early, I guess mid 2000s, there's this big push for test-driven development, which was like you write the unit test first, essentially. Like you know what you want out of your function, you know what the function's supposed to do, you know what operations aren't supposed to happen in the function, and you test for all of those. So you write tests for them. So unit tests are essentially they're designed to capture really granular success and failure information, like around a function or around the change of a variable. And you're hoping to be able to catch any potential issues that might come up with this function. So you test all of the potential inputs, including stuff that's out of range or stuff that shouldn't work, and you make sure that it does what you expect it to do. And that way you can come back to it later and know that it's working exactly as you expected it to. When you wrote the unit tests, sometimes obviously that changes and then you have to rewrite a bunch of tests. But so that's what I think a unit test is.
Yeah, that definitely fits with my understanding as well. And actually, I learned about test-driven development very early in my coding career because I took a software carpentry course.
Oh, fun.
And that was like one of the first things that they talked about was first you do the test, or like you have an idea of what things should look like, and then you build a thing to do it, which I also think is super applicable to data cleaning, because usually data cleaning, I know what I want the final data set to be like, or like the format, or I know that I want this to be like, I want everything to be normalized or whatever for whatever I'm working on. And then the data cleaning is, that's what I need. How do I get to there? And then how do I check that it is, the way that I want it to be once I'm done? And like, usually the answer is with my eyes and a data frame, which is maybe not the most robust process.
I know when we do a lot of data cleaning and prep. I tend to write a lot of they're kind of like unit tests. Because we're doing it in a Jupyter notebook, it's a little bit tougher to do.
Yeah.
We write a lot of asserts and make sure that a piece of data looks exactly like we think it should at that exact moment in time and matches up with everything. I do a lot of that, and I suspect the rest of the data scientists do as well.
One thing that I always found interesting, not always found interesting, but lately I have been trying to do, and Phil and I have been discussing this quite a bit, is how to unit test on models. The reason that we were talking about this is because for some of the evaluations, we actually need to run neural network on them. And it's kind of like if you retrain your neural network, you still want it to be good enough on basic things. Yeah. For example, if you have a dog and cat classifier, but you want to add like a new breed of, let's say you want to add hedgehog into this classifier, but you don't want the dog and cat to break. Then you probably want the dog and cat data to be in your unit test, and we were talking about how to set up that kind of unit tests into your into your model, such that in the future we'll have more and more automatic retrain, and you want to make sure that your quality of your model is still up to a certain standard.
Yeah.
And probably it should be not just like a few cases, it probably should be like, pass through an entire data set, and making sure that your performance or some sort of metric is up to a standard before you can deploy this version.
Yeah. It seems like that would also be really important for human in the loop learning, because you want to make sure that you're getting good annotations, and if you're crowdsourcing, you want to make sure you don't get bad actors. And
that's a cool point. Yeah, I did an active learning project probably 5 years ago at this point, maybe 6. And that was an interesting part of the problem. I know I wrote unit tests for all of the engineering parts of it. I don't think I thought to write unit tests for the people in the loop, though. That's a really cool idea.
There's some tricks that I have a background in social science, and like when crowdsourcing started to be like a thing that people would use to collect data, there were some like tests that you'd sprinkle in there to see if people were paying attention. So like questions with like switching the scales in the middle of the questionnaire, or just like an arithmetic question in the middle of this like scale, just to make sure that people were actually reading and paying attention, and using that to check people out. But that's more for data collection than active learning.
Yeah. I was trying to think, how would we test that? That's a really interesting problem. I'd love to. We should dig into that at some point, because I'm sure you'd have really great ideas. So I know in all of my previous ML engineering work, obviously you unit test all your engineering stuff. TD, test-driven development, is pretty like restrictive, right? Like, you have to write a lot of tests, and sometimes it's too many tests, and it can slow things down. So I know that as an industry, I think we've kind of moved away from that. But you still write comprehensive. You get good test coverage, which is like writing tests for as many of the units as you can. But in terms of testing the models, you kind of have to understand a lot about what your model is supposed to be doing. So, you can do like pretty straightforward, like end to end, like, oh, I'm going to put this data in and make sure that the model finishes and that it has results. And, so you can do the engineering pieces around the model and make sure that stuff is coming out and going in the database or whatever. But in terms of actually testing whether the model is doing what you hope it does, that's kind of a different thing, and it does require a level of understanding about your model and
the distribution of your data as well.
Yeah, exactly. And it requires you to make some assumptions too about how your data is going to be distributed. And I've definitely run into problems with that in the past, where it was like, I did a lot of NLP work. So, text, so evenly distributed, you always know exactly what it's going to look like. You're passing stuff in, and then it's like, oh, well, something random breaks it. And it's not even like, it's not an engineering problem. It's that you broke your model.
Darn. Yeah.
So I'd love to kind of hear what you guys think about how that works. Maybe offline, possibly, since that's kind of a deeper discussion. I'm kind of
curious how your team does testing, especially with the data sets.
Yeah.
Do you have files somewhere, or is it integrated in the...
You mean file, like the ones that I was talking about? Yeah, we those are checked into part of our repo. Yeah, so those are, so since they're unit tests, so typically they're just simple canonical kind of examples, and so yeah, sure, we can check those in. Yeah.
So you don't generate a new file every time? We
don't. Yeah, because there's no, in some sense, there's no point of doing that, right? Unless, sure, you can say let's randomize some, maybe the input, but it's like now you're getting into the place where you're like, okay, maybe then this test would sometimes work and sometimes doesn't work, then becomes a flaky test. Then it's really hard to find out. Like when it breaks, then it's like, what happened, right? Yeah, you can't go back to the input anymore.
I guess that is one difference between machine learning
Yeah.
and sort of like engineering in general is that sometimes things work and that's fine in machine learning.
Yeah.
Well, it's not fine, but it's just the way it is. Whereas in engineering, you do want it to always work.
It's like one input and one output. Yeah, that's why, like when you guys were saying testing the machine learning model, yeah, I guess you're just checking passing a certain threshold, and that's it.
If it's a model, then
Yeah.
probably. Yeah.
Right.
Because you don't expect the scores to always be the same because
Right.
you're changing your model.
And you can't expect the weights to be the same, right?
Right.
Yeah.
Yeah.
Not unless something really freaky with transfer learning happens where you like like the odds of that are just infinitesimal.
Yeah, that would be wrong, right?
Right?
If that was actually happening.
You'd be
So
like,
there, and you know, when you're testing your models, there's most of what you care about isn't really whether or not they do what they need to do. I mean, you hope that they do what they need to do. You assume, and you know, you build the test around the code, but you're really concerned with how is the model doing. Like you're more concerned with evaluating the output. So there's this tension between, you know, instrumenting to dig into your model and doing things like randomizing to make sure it generalizes and stuff like that, but then being really worried that you don't really have a handle on whether you're getting the results you want. So it's really complicated.
That's actually interesting. So there's like the classification, like the performance test.
Yeah.
And then there's the generalization test.
Mhm.
There's the bias test,
Yeah.
for example. And
It's like, you know, and I guess it makes sense to kind of, you know, break all of those out and structure them differently because they really need different things.
yeah.
That's an interesting, I guess that would be one way to approach unit testing a model then, is to figure out all of the, you know,
Different things you care about.
yeah, all the things
Yeah.
you care about and figure out how to test them. That's a cool way to do it.
Yeah. I don't think I've heard anybody talking about that particularly.
Because it's, you know, usually you're spending so much, you know, wall clock time on your end to end, like just getting through, even with like small sample sets, it can take a while if you're doing something complex. So you know, you're not looking to increase your test unit volume, your unit test volume by like, you know, 6 times or whatever, by covering like 6 different things. But that's kind of the only way it makes sense.
yeah, that's what I was asking Jackie about. Like, do you have actual files that live in like a bucket somewhere that you pull in, or is it checked into the code base?
So this one is particularly checking into the code base because we're testing that decompression unit, and we do have some kind of like browser tests, more like an integration test that's, you know, actually uploading the data files and then making sure that it actually generates a data set at the end. So but it's hard to generalize. Like we can always like have a even larger data file that we want to put into for these kind of automated integration tests. But you start to run into like the length of the like amount of time that you want to put in for testing just to get one build, right?
And then you have to run all your tests every time you commit, right?
Yeah, every time you, not every time you commit, but whenever you check in and merge into the production system.
And if that, like going from like 5 minutes to 10 minutes there is a huge,
and potentially more.
yeah.
Yeah, that's the part that I worry about for the models, because then you'll have to have a lot of data. Like, let's put ImageNet in there. And then we see the performance, and like, okay, it's gonna take a while.
Yeah, especially image models, because like even a big text data set is not as big as a small image data set.
Yeah.
And you mentioned integration testing.
Sure, yeah.
I know about integration testing from engineers posting memes, but not like what it actually is. So do you want to talk about it a little bit? And is it data science? Should I be doing this?
Sure, let's do it.
Okay, I know probably less than you guys do, but so from my point of view, the integration test is more like you're just piping through, basically having an input from potentially at a very high level, potentially at the API level, endpoint level, and then just making sure that everything works out well at the end, like a data set is being published, for
So
example.
instead of like testing each chunk individually, you make sure that they work together.
Right, yeah. And then typically, I think people don't focus a lot on the integration tests just because, like, yeah, if one, for me, I think I focus on unit tests way more than integration tests. First, it's easier to set up, and like time takes is running one integration test is probably longer than running like a few small unit tests. And also, like, if one unit test fails, then you know where to look at. Whereas like integration tests, you actually have to dig in stuff. Yeah.
Yeah, I know.
Yeah,
You know,
fits.
Yeah, when at previous jobs when I was deploying machine learning models, you know, we would do integration tests. You know, we would push to a staging area, or to like a mock network of servers. Because sometimes we had lots and lots of servers doing stuff, and run our integration tests, and then push to the client's mock setup and also run integration tests, and then finally like move to prod and then run integration tests there as well. But
That's impressive.
Yeah.
Well, you catch a lot of stuff. If there's delta between your environment and their environment, you catch that. If there's a delta between their prod and their test, then you catch that. And
just like having like flashbacks of CUDA version differences.
Oh my gosh. So yeah, I mean, that's like, even if you're pushing like containers, there's a possibility that like, your GPU can get disconnected and everything can go horribly wrong. So yeah, CUDA version differences. Yeah, that's really terrifying. But we were super selective about, we would only do that when the chain is going to go this way, like, so unit tests you do every time every time we made any changes, since we were doing both R and D. Right.
What's an example of an integration test for a model, a production model?
Okay, one of the things that we were really worried about, so taking known data and pushing it all the way through and making sure we got known outputs, and that our midpoints were all kind of hit. Like, okay, our NLP, our negation system is doing what we expect it to do. So when the integration test is happening, you have it pump out what it is you're looking for, which is usually just checking that the negation code runs, and that your engine spins up and everything. So an example would be, you're going to push. You want to get your new full system. So that's the point of the integration test, is the full system gets tested. Your new system is going to bring in like 2 new servers, because you've got a new database that's, for word embeddings, and you've got a new server that is going to be running your NEX or something. And so what you do essentially is we had a known data set that we could push through and get our known outputs. And then at each step of the integration, we'd make it harder. So here we do like a small known set. Here we do a set that's bigger and includes the small known set, so that we get our known outputs, but we're also like testing scale. And then when we move to here, then actually I would let the client pick a data set to run past it. And that's more of like a smoke test. Like, is it going to work with your data? Are all your things set up? Like, are all your wires not crossed? And so, yeah, that would be like a example of a deployment, I guess, sort of.
So that sounds to me more like what I would think a machine learning engineer would do. Because I don't know if you guys would agree with this, but I tend to see more job posting now where like that, I'm putting it into production, I'm building the system, I'm setting up the pipeline, tends to be called more machine learning engineer.
Yeah.
And the data scientist is more developing models, doing data cleaning, discovery.
Yeah. I would definitely, for the last 20 years, I probably would have called myself more of an ML engineer than a data scientist.
I'm not going to worry about integration tests then. That's what I've gotten from your answers.
I think the cool thing is, though, that we're all ML engineers in some way or another, right? Like I've seen stuff, in your, the things that you put online that you post about, and you're talking about like the same stuff I was doing, just, it's happening at a bigger scale in production in like a, big corporate environment, but I'm sure you'd be able to scale it, right? And knowing that this is a good idea is kind of universal, I think. That you want to be able to trust your code, you want to be able to trust your models, and you want whoever's using it to have those two trust those two things too. So I think it's kind of key for everybody. Like, maybe you don't want to write a lot of tests. And, when we were doing like just research, you want to iterate as fast as possible.
Yeah. If you're only going to run the code once, there's no point.
That's a good point. Yeah. If you're only going to run the code once, that there's no point. If you're going to run the code 10,000 times in the next week because you're changing things and seeing how it changes the output, then you want as few unit tests as possible.
Yeah.
And I would actually use a modified form of our integration test for checking. Well, because you're checking how your model changes things. So great, run it end to end. It's a great way to do an integration test, but you also shorten it up a little bit. But I think that everybody can do this kind of stuff and get a lot of impact out of it. I mean, I wasn't doing it because I love writing tests. I was doing it because it it was like, for the amount of work you put in, you get just enormous amounts of trust in your own system out of it.
Yeah. Which
and
avoiding bad whoopsie daisies.
And avoiding very bad whoopsie daisies. And sometimes, like I said, it would change between here and here and here, and the whoopsie daisy would at least be, you'd be able to say, well, we know what worked here.
Yeah.
We know what worked here. If it's failing here, these are the unknowns, because we know exactly what the knowns are. And we just looked at the knowns in the last 5 minutes. So it gives you a stronger baseline to work from, which I think is kind of critical for even people who are doing, iterative data science stuff. Yeah.
Well, before we wrap up, I just want to do a quick whip around. I always ask people if there's anything in particular they want to share with the Kaggle community. Just open the floor. Jackie?
Oh God.
You don't have to have anything, but like if there's anything you want to share.
Anything? Doesn't have to be related to testing.
No, just in general.
Of course. Yeah, upload more data sets.
Upload
Make
more
them
data
public.
sets. Hey.
Make them public.
Yeah.
I'll be running my quarterly ciphertext competition.
Yay.
There have been so many cool cryptanalysis kernels. There have been great visualization kernels. If you're interested at all in ciphertext, in encryption methods, in simple ciphers, like in NLP, because it's all NLP, hop in and look at the kernels in the last one, the ciphertext.
I feel like you're talking to me specifically.
I am. Maybe I am. But it's super fun, and we've gotten some really amazing, feedback from it. And I think the more people that participate, I think everybody can just have so much fun in it. So come play in the next one as well, and in the previous ones. Play in the previous ones.
Maybe try out the previous ones and then
yeah, totally. See what you can. I mean, the solutions that people post are so cool. They're coming at these things from so many different angles. It's awesome. So.
I'm gonna be launching a GAN competition soon.
Oh, that's right. That's
Very
right. We talked about it
excited
at
about
Kaggle days.
So yeah, please come join. Generate some dog images.
Is that the subject?
Yeah, pretty much just for my own personal
Delight.
interest. But we can run the next one as a hedgehog. You just have to have enough images.
I feel like hedgehogs would be harder for data augmentation. Sorry, I promise this is relevant. There's a cool toy store near here, and I got a little, where's the camera? It's a little squishy corgi, and he's wearing
Oh, that's so cute.
a little dinosaur costume. Anyway, sorry, you reminded me. of the little dog I got, which I guess is what I want to share with the Kaggle community.
This can go into the holdout private set.
Oh my gosh, that's a great idea.
So that's a tip from us to you.
Oh my gosh.
So craft this.
No, like I feel like dogs would like dog toys of dogs would be a really interesting little wrinkle.
Oh.
Okay. Yeah, I think I shared my thing. So thank you so much for making time to join me. Yeah, making time to join me today. We're all really tired. It's been a long week.
It's been a long week.
And I'll see you guys like again right now. And I'm sure we'll have another chance to chat with Kaggle. So
Thanks for inviting and thanks for watching.
Yeah, thank you.
of course. Thanks for watching. Stop recording.